Hello, welcome back. In this video, we're going to find vertical asymptotes of the function cosecant pi x. And this is a trigonometric function, and we know that cosecant is defined as 1 over sine. So it's in fact a rational function for which the top function is 1, so this is the top, and the bottom function is the sine function. For the existence of vertical asymptotes, we are looking for x's that makes the top non-zero but the bottom 0. Well, the good news is that the top is already 1, which is non-zero. So all we're going to investigate is if there is any x that makes the bottom 0. In other words, we are solving sine pi x equals 0, the equation sine pi x equals 0. So at this moment, it's very useful to have the unit circle with you. And all we're going to do is to check where the sine function takes the value 0. Because there are multiple solutions, there are multiple places on the unit circle where the sine would be 0. For example, x equals 0 is a good candidate, and x equals pi is another candidate for the sine function 0. But this is sine pi x, so if I choose x to be 0 or 1, as you see, these two would satisfy this equation because x equals 0 makes this inside 0. Sine of 0 is already 0. And x equals 1 makes the argument pi times 1, which is pi. And sine pi is 0. So 0 and 1 are only two solutions that I came up with real quick. But there are more solutions because if you choose x to be 2, and you get sine 2 pi here, that is still 0. So any integer value for x is going to solve this problem. So in other words, it's 0, plus minus 1, plus minus 2, and on and on and on. So for this rational function, there are multiple x values that will make the bottom of the function 0, but not the top. Since all of these define lines, so there are multiple lines making vertical asymptotes, and the first one is x equals 0, which is the y-axis. The next ones are x equals 1 and x equals -1 lines, and then x equals 2, -2. And if you graph the function cosecant pi x by using your calculator, and here's a tip for you, there's no cosecant button here. So all you can do is you can define your function to be 1 over sine pi x, and don't forget that you set the calculator to radian mode. This is what you get after we graph the function. As you see that at every integer, like -4, -3, -2, -1, and 0, 1, and 2, you have a vertical asymptote. And in like if you look at the sides of the vertical asymptotes, in like for example x equals 1, the function goes to infinity on the left and minus infinity on the right. And for this one, infinity on the right and minus infinity on the left, you can actually see individual behaviors around the vertical asymptotes. All right, that's the end of the video. Thanks for watching. I'll see you in another video. Bye.